In this video, we're going to study gradient a bit further than we have before. So let's just recap a wee bit what we already know. So given a line which joins 2 points, x1, y1 and x2, y2, we can already find the gradient by examining the shift in the horizontal and the shift in the vertical. So the shift in the horizontal here is x2 minus x1, and the shift in the vertical is y2 minus y1. Now we know that that leads to our formula that we're used to for gradient, and we still will be using a lot. So gradient is equal to y2 minus y1 all over x2 minus x1. So that's the shift in the vertical over the shift in the horizontal. Now, I also know for right angle triangles that I can apply trigonometry. So if I just put my angle in at the bottom left of the triangle here, so that's theta, I know if I label this that across from the right angle is my hypotenuse, across from the angle theta is my opposite, and the other side is the adjacent. Now, I know that if I want to find tan of the angle, so the tangent of the angle, I get opposite over adjacent. Okay, so that's, you'll have learned that before in right angle trigonometry, or you would know it as SOHCAHTOA. So this is the TOA part. So actually though, isn't the opposite y2 minus y1 and the adjacent x2 minus x1? And then doesn't that relate to our gradient formula up above? Because we can see that those are the same. So surely then that means that the gradient coming from here is the same as tan theta, which gives us a new formula. So m equals tan theta. Gradient is equal to the tangent of the angle. So it might be worth recording just that formula just now in your notes jotter. That's quite important and we'll use it quite a lot. So make sure that you know that and you remember it. So if we just look at this, m equals tan theta. Now this formula works when we have an angle, we have a line, and it's the angle that that line makes with the positive direction of the x-axis. So the positive direction of the x-axis is obviously going this way. So going to the right, because the numbers are increasing. Okay. Now, the diagram that I've put nearer the bottom here, you can see that that's got a positive gradient, because going from left to right, the line is going up the way. So that's got a positive gradient, and it's an acute angle. And if I look at my tan graph, acute angles lie in here, between 0 and 90. And you can see that the value of tan between 0 and 90 is positive, okay, because it's above the x-axis, and that's why we get a positive gradient here. Similarly, if we've got a negative gradient, so from left to right, the line is going down the way, and you can see that the angle between the line and the x-axis is an obtuse angle, so it lies between 90 and 180. So here's between 90 and 180 in the tan graph, and you can see that that's negative because it's below the x-axis. And look, we had a negative gradient. Now if we've got a horizontal line, so that's we've got a gradient which is equal to 0, because it's flat, there's no slope whatsoever. If we look at our tan graph, well, when tan of 0, tan of the angle 0 is 0, so that gives us a 0 gradient as well. Okay, so it's all justified back to the graph of the tangent function. which we would have met last year. Finally, if we've got a vertical line, so we know so far if we've got a vertical line, it's got equation x equals, and whatever that may be, and it's got an undefined gradient, okay, because it's gone all the way up. It's gone from 0. If the line was flat and you travelled that distance through the 90 degrees up to the vertical, it becomes undefined. Now, if we actually look at the tan graph and we look at tan of 90, that's that line there, that is actually undefined. The tan graph doesn't go through those red lines that appear. Those are called asymptotes, and the line will never go through there. So if you put tan 90 into your calculator, it will come up with a math error, and that's because it's an undefined gradient. So it all links back the gradient and the tan graph as well. So let's look at some examples, folks. So after each one of these, remember, pause the video, copy them down, and it'll be good for when you go on to do the work. So example 1, calculate the gradient of the straight line shown in the diagram. So the solution. Now, firstly, I'm noticing that obviously I've got the line here, and the angle that I'm given is the angle between the line and the positive direction of the x-axis. So that allows me to use my formula, m equals tan theta. So that's always the first observation. Is the line making the angle with the positive direction of the x-axis? So substituting in, I get m equals tan 32. Putting that into my calculator gets me 0.625, and I'm stating that I've rounded that to 3 decimal places because it's not an exact value. Okay, so like I said earlier, you can copy that down in your jotters. Now, example 2. So find the angle that the line joining P -2, -2 and Q 17 makes with the positive direction of the x-axis. Now, slightly different this time, so we're asked to find an angle. So in the previous example I was given the angle, but I know that if I'm working backwards as such, I can use the function inverse tan. So that's fine, we can do that. But we're also given 2 points this time as well. Now, the diagram, if I had to draw that, would look something like this. So I suppose I'm expecting an acute angle here. This is what my answer is going to be. And here, if you just look at my cursor just now, that's what I'm looking for. Now, firstly, could I find the gradient of that given line? And the answer would be yes. So the gradient of PQ, and remember I said it's really important that you always in higher, you always label what your gradient is. So your gradient PQ is 7 minus -2 over the x ordinates 1 minus -2. So that's y ordinates over x ordinates. So that'll give me 9 over 3, 9/3, which gives me 3. And I can see that 3 would probably be correct for this, for the gradient of this line, because it is going up the way, that's why it's positive, and it's quite a steep line, so that's why it's a whole number, 3. Now, I can then look at m equals tan theta. Now this time I know my gradient, I know that it's 3, so 3 is equal to tan theta. Now in order to get theta, I need to use the inverse of the tangent function. So theta is inverse tan of 3. And when I put that into my calculator, folks, I'm going to get 71.6. Which you can see that the wee arc that's been drawn in here, that is probably around 71.6. If I'm putting the right angle in with my cursor here, so you can see that that is around the 70 degree mark. So that's the correct answer. Now, moving on to example 3. So the line AB makes an angle of 60 degrees with the y-axis as shown in the diagram. Find the exact value of the gradient of AB. Now, I suppose the first thing to be noted here in this is that the line AB is making an angle of 60 degrees with the y-axis. Now, if you think about the formula that we're currently studying, m equals tan theta, theta has to be the angle between the line and the x-axis. So obviously this is between the line and the y-axis, so that maybe poses a new sort of element to this question. Now I'm just going to redraw the diagram here. Now if I use vertically opposite angles, I know that the angle that I've put in there is also 60. So you might have referred to that before as x angles. If I extend my line further back a wee bit, I can see that the line and the x-axis are now hitting each other, so that's good, they now intersect. I've got my right angle there between my x and y axes. So given that the angles in a triangle add up to 180 degrees, this angle here must be 30. And that now is the angle that the line makes with the positive direction of the x-axis, because this is positive direction here. So I can see that the angle I'm looking for is 30. Now, another way to look at it would be to sort of mirror my x-axis, so bring that, put in a horizontal line where the line AB meets the y-axis. And you can see that, well, that would be a 90 degree angle because it's a horizontal line and my y-axis is a vertical line. So if I've got a 90 degree angle and I know one part of it is 60, then the other part of it needs to be 30. And that's also, because it's a horizontal line, that is going in the positive direction of the x-axis as well. So I can use either method to get my 30 there. And then it's quite simply a case of, I know that the gradient formula is tan theta, m is equal to tan 30, and we will learn about exact values quite soon in higher, and you'll need to know them off by heart, but at the moment I'll let you use your calculator for this. So your calculator will give you 1 over root 3, and that is an exact value because it's as a third, it's as a fraction. So generally when we're asked for exact values in higher, it's because it's a third or a fraction. It so happens that tan 30 is both a third and a fraction. Okay, so again folks, if you copy this down in your notes jotter, and you only need to take down one of these diagrams, so just take down your preferred method. So example 4. So find the size of the angle theta shown in the diagram. So I suppose again it's worth noting here that this angle theta is the angle that the line is making with the y-axis and not the positive direction of the x-axis. So we firstly know that we've got the gradient, it's 5, but we also know this formula, m equals tan, I'm going to call it x this time because theta is already in the diagram, and you'll see in a moment why I'm not putting theta into my formula this time. So m equals tan x, I know that 5 is equal to tan x because 5 is the gradient, and in order to find the angle x, I need to take the inverse tan of 5, which is 78.7. Now, 78.7 is actually this angle here, or this angle that the line makes with the positive direction of the x-axis. Okay, so you can see here that we've got corresponding angles. You might have referred to that before as an F angle. Okay, so corresponding angles. But in actual fact, that angle here, 78.7, allows us to work out what theta is. You can see that this is a right angle in here. So theta is 90 minus 78.7 degrees, and that gives us 11.3 degrees for theta, which is our final answer. Again, folks, it's a good idea to copy this one down and then go and complete the assigned exercise.